I want to tell you about a totally radical idea. But first, let me tell you a little bit about my history. When I first got into science, I was a young pre-med student. I joined a chemistry lab, trying to understand a material called mesoporous silica. I then went on to graduate school and did a PhD combining materials science with microbiology. I was using a material called quantum dots, trying to understand things we could do with this new material. I then went on and did a postdoc and got back into human biology and human medicine, which is where my interest lied. Finally, when I started my own lab, I took these seemingly disparate experiences and put them together, where we now study metabolic regulation from a biochemical and chemical perspective. Each of these starts and restarts across disparate fields required me to do a lot of reading. It seemed like a good idea at the time. Read the literature, get comfortable with the field, try to absorb as much as you can, and then hopefully come up with a brand new idea that you could then bring into the lab to carry out and test. But the thing is, this approach no longer works. The sheer volume of information that is required to learn to understand a field is outpacing anyone's ability to understand it. So in this video, I'm going to share with you a radical new way to approach your science in order to come up with new ideas. Now, if you're not a scientist, stick around because the principles here are going to be broadly relevant regardless of your area of interest. Let's dive in. This realization that we needed a new approach came a few years ago. So the lab does a lot of omics approaches to understand our science. This is where we generate a lot of data to measure genes and proteins and metabolites in our systems of study. So we do these omic approaches and we get a lot of data. I mean, like a lot of data. After too many times of manually crunching numbers, I realized there has to be a better way. I think a lot about systems. So I thought to myself, there must be a system that we could use in order to analyze our data in a much more efficient way. The emerging field of data science uses tools to turn data into information and ultimately knowledge. I tried to convince the lab that we need to dive into data science in order to analyze our own data. But the thing is, no one listened. So classically, I said a little louder, we need to be able to analyze our own data. And still, nobody listened. So I said, fine, I'll just do it myself. Like anything new, it was hard at first. I carved out time between the hours of 9 p.m. and 1 a.m. after the rest of my family had gone to sleep. But like any learning project, a little bit of time plus consistency meant that I was slowly, steadily making progress. And sure enough, little by little, I spent more and more time programming, using data science and the tools of data science to solve more and more problems. So how does a pre-med student, turned chemist, turned molecular biologist and physiologist, turned computational biologist, traverse through these seemingly disparate fields? I think there are three key principles, and that's what I want to tell you about in this video. First principle is explore. Because creativity is connecting things, you need to have an exploratory mindset in order to find new ideas to connect. As Linus Pauling famously quipped, the best way to get a good idea is to have a lot of ideas. And you never know, a circuitous route might lead you down a new and important path. 2. Always experiment. A flurry of random activity does not result in mastery. Instead, this is going to seem a little redundant, but thinking like a scientist and running experiments to understand the problem and then systematically explore the solutions is what leads to learning. But importantly, you can also do experiments about learning. If you're watching this video on YouTube, then you already know there's a treasure trove of information at your fingertips. But we should ask ourselves, what are other people doing to learn the thing that I want to learn? We should explore where innovations are taking place. We should be looking at what course-based cohort creators are doing and other experiments in education that are playing out across digital spaces. By exposing yourself to new ideas, you will not only learn what is happening, but also then what is possible. 3. Imagine the future. When trying to consider solutions to a problem, I often say, suspend reality for a moment. This trigger creates a safe space where you can then, unconstrained by the bounds of reality, explore different solutions. So suspend reality and think, what could be possible? What could possible solutions be? This exploratory mindset, of course, is going to be distinct from the evaluative mindset, where we then go through and say, that was a terrible idea, throw out that one, and so on. But suspending reality allows you to explore possible space. Radically reimagining possible futures requires radical new ideas. Skeuomorphism is a new idea I recently heard about that I think is incredibly relevant for this conversation. It was originally a term used by graphic designers, particularly graphical user interface or GUI designers, when thinking about designing a new interface for computer software. Skeuomorphism refers to designing something in the digital space that recapitulates physical reality. So what are a couple of examples? First, a classic example is the file folder structure of all of our operating systems. We store files in folders in a filing cabinet, and therefore recapitulating that activity within a digital space was really familiar. Another example, when we want to get rid of something on our computer, we throw it into the trash bin or the recycle bin. Again, these skeuomorphic ideas are digital representations of our physical reality. Now, the benefits of skeuomorphism and this skeuomorphic thinking is that it allows a brand new interface to become immediately familiar. If we want to get rid of something, we just put it into the trash. However, skeuomorphic thinking also has its limitations. And this is a really key idea. Digital spaces allow for new interactions that are completely untethered to our physical reality. So let's go back to the file and folder structure. One of the big innovations in the transition from this first skeuomorphic design into the way that we think about files now is a really simple idea called tagging. Of course, we can take a tag and we can put it on a file, and a file can have an infinite number of tags. It doesn't matter. And we can search for our tags and recombine documents in digital space. Now, this is impossible in physical space. You can't have multiple collections of the same thing located in different physical places. So if we were just going to stick with our skeuomorphic thinking, we would then be constrained by physical reality. But our second iteration, where we are suspending reality for a moment and unconstrained by physics, means that we can completely reimagine and redesign the experience. Here's another example. The first mobile phones, if you remember, had pens or physical keyboards in order to enter information into them. Now we can use voice dictation. Again, this is a second iteration, discarding our skeuomorphic thinking and designing something for this new digital reality. See, skeuomorphic thinking is stuck in the real world, but our future is not. Now, I've learned these lessons through science, but these principles are not restricted to scientific disciplines. In fact, a new Silicon Valley battle cry is experiment like a scientist. Indeed, these principles are being applied across disciplines. The Nobel laureate Niels Bohr famously quipped, "It's hard to make predictions, especially about the future." You can't know how an experiment will turn out before you do it, but you also will never know how an experiment will turn out if you never do it. So, as you suspend reality and think about possible new futures, some might look on and think that your ideas are completely radical. But experimentation is the only way to reimagine the future. Thanks for watching. We'll see you next time.